Hi viewers, Vanakkam, Vandanam, Namaskaram. You are watching Aha Namma channel. It's full and full education and entertainment. Watch the video carefully and learn it everything.
Now that we know how we can find the square of a number, we can try to understand what square roots are. This is a topic which many students find really difficult to understand. So here's your chance to understand this topic well and score better. Consider any number. Say 4. 4 when squared gives us 16. And the square root of 16 gives us 4. Well, that's your concept. Now we shall see how we represent square roots. This is how we would represent the square of 4. 4 raised to 2. 2 is called the power and 4 is the base. Now how do we represent the square root of 4? Well, this is how we write it. This symbol is called the radical or the square root, and the number inside the symbol is called the radicand or the base. That's the first thing we learned, how to represent a square root. But here's a simple way to remember it. We know that 5 squared is 25. This 2, when transposed to the other side, becomes a square root. So we can say that the square root of 25 is 5. Now let's look at something really interesting about the square roots. What's the square root of 16? Yes, it's 4. This means that if we square 4, we will get what is under this radical. Similarly, the square root of 256 is 16. If we square this, we will get this. Now let's try playing with these numbers. Let's try writing 16 in exponential form. We know that 16 can be written as 2 raised to 4. So the square root of 16 can be written as the square root of 2 raised to 4. It's the same thing as the square root of 16. Can it be written in some other way? Yes, it can also be written as square root of 4 raised to 2. We just wrote 16 in two different ways, 2 raised to 4 and 4 raised to 2. Now let's try writing the number 4 in different ways. 4 can be written as 2 squared, hence this will equal 2 squared. The number 4 can also be written as 4 raised to 1, hence this would equal 4 raised to 1. Just look at these things now. What do you observe? What happens to the base and what happens to the exponent? Let's look at the first example. The base remains the same, but the exponent is halved. It's divided by 2. Now let's move on to the next expression. Again, the base remains the same and the exponent is halved. Does this work every time? Let's see. This can be written as square root of 2 raised to 8, or maybe even square root of 4 raised to 4. And 16 can be written as 2 raised to 4 and even 4 raised to 2. In this case, the base remained the same and the exponent was halved. And in this case too, the exponent was halved. So remember, when you have a number in exponential form and you want to find its square root, just keep the base same and halve the exponent. The easiest way to find the square root of any number is to use a calculator. But if you're asked to find the square root of a number without using a calculator, there are two ways in which we can do it. The first method is phenomenally simple. It's called the prime factorization method. We will look at the second method in the coming videos. If you have watched the previous video, you should be familiar with what square roots are. So we can look at square roots of slightly larger numbers in this video. So we want to find the square root of 225. Our aim is very simple. We have to reduce this number to its prime factors. That's all. How do we do it? Before we go ahead, let us revise what prime numbers are. A prime number is a number which is divisible only by itself and 1. Say 5. 5 is divisible by 1 and it's divisible by 5. There's no other number which can divide 5. 1 and itself. Hence, it's a prime number. Let's consider 8. 8 is divisible by 1, 2, 4 and 8. Apart from 1 and itself, it's also divisible by 2 and 4. Hence, it's not a prime number. So let us start reducing the number 225 into prime factors. Prime factors are the factors of this number which are prime. We can write 225 as 5 multiplied by 45. 5 is prime, but 45 isn't. So let's reduce 45 further and write 225 as 5 times 5 times 9. We wrote 45 as 5 times 9. 5 is a prime factor, but 9 isn't. 9 can be written as 3 times 3. Hence, 225 can be written as 5 times 5 times 3 times 3. In this way, we reduce 225 into its prime factors. This was simple, but is it the quickest way? No. Let's look at a quicker way. We write 225 like this and draw 2 lines here, like this. 225 is divisible by 5, so we write a 5 here. We just write the prime factors in this column. 5 multiplied by 45 gives us 225. 45 is not prime. Hence, we continue with this process. 45 is also divisible by 5. Hence, we write a 5 here. And 5 multiplied by 9 gives us 45. 9 is not prime, and we can say that 3 multiplied by 3 equals 9. That's where we stop, when we get a prime factor here. So if we look carefully, we have got all the prime factors. 5 times 5 times 3 times 3. Why do I say this method is faster? Look at the first 5 in this method. We continue to write it every step. Then we repeat the 5 times 5 we got in this step in the third step. Many of the numbers are repeated in every step, and hence there's a bit of a redundancy. If you really want to know how tedious this method can get, try reducing 216 into its prime factors. By now, we should be fairly comfortable with prime factorization. But now we're getting to the most important point. How will this help us find the square root of 225? You will not believe how simple it is. We write this as square root of 5 times 5 times 3 times 3. We have to make groups of two same numbers. This can be our first group, 5 and 5. We can make another group, 3 and 3. We basically formed pairs of same numbers. So we have two pairs of same numbers here, 5 and 5 and 3 and 3. Once we form pairs, to find the square root, all we have to do is pick one number from each pair and multiply them. So from the first pair, we pick 5, and from the second pair, we pick 3. And we multiply 5 and 3, which gives us 15. At first, this seems long, but with practice, it gets very simple. Hence, we can say that the square root of 225 is 15. All we did is broke down the number to its prime factors, made pairs, chose one number from each pair, and multiplied them. In the next part of this video, we will see how we can find the square root of 11,025 using this method.
In today's video, we're going to find out which number to be multiplied or divided to get a perfect square number. Now, let us take an example here. Suppose I'll take a number 1458. Okay, this number is not a perfect square number. If it is not a perfect square number, we cannot find out a square root for this. So which number, which is the smallest number to be multiplied, or we can divide it to make it a perfect square. So this can be done by prime factorization method, and this method I have showed you in my previous video. So let us do prime factorization for this number. Okay. So I'll start, since this number is an even number, I'll start with 2. Okay, so 2 and 14, 9. Again, this is odd number, not going to, so let me take a 3. So 3, 2 is 6, 4 is 12. Again, this will go in 3 table, so 3, 8 are 24, 3 1s are 3, then 3 2s are 6, 7s are 21, then 3 9s are, and then 3 3s are, and then 3 1s are. Now the entire process I have showed you in my previous video, how to do the prime factorization. You can go through that video. Now I can write 1458 as 2 into 3 into 3 into 1 2 3 4 5 6 3 4 5 6. Yes, so I'm going to start pairing up. Okay, this is what we have done in prime factorization. So this is my first pair, second pair, and third pair. Here I don't have any pair for this number 2. Okay, so I don't want either. I want one more 2, or I don't want this 2 at all. So when we have to multiply, okay, what is the smallest number you have to multiply? So the smallest number to be multiplied will be 2, because I have one 2 already, so I want one more 2. So for that I have to either multiply with 2, and then if in case of divide, okay, I don't want this 2 at all. To remove this 2, I have to divide 2. So in case of multiplication, you have to multiply it with 2. In case of division, you have to divide with 2. So if you divide with 2, this 2 will completely removed. In case of multiplication, you have to multiply with 2, so that you'll get a pair, and then you have to get the square. Suppose in case of multiplication, I have to multiply with 2. Okay, so my number, perfect square number, will become like 2 in case of multiplication. Okay, so 2 into 2, if in case I'm multiplying this 2 here, and 3 into 3, 3 into 3 into 3 into 3. Yes, so this is first, second, third, and this is fourth pair. So your number will be, so square root of I have to get the perfect square, right? So this will be, you have to multiply this number. So when you multiply all this number, you will get 1458 multiplied by 2, which is equal to so you will get 2916 as your answer. This is your perfect square number. Okay, so when you find out a square root of 2916, you will get your answer as 54. Okay, now let us take an example for division. When I have to divide a number with 2, so I have to remove this 2. So when I remove this 2, I have to just multiply all these 3's. Okay, so when I multiply all these 3's, or you can either write 1458 divide by 2. Either you can divide this, or you can multiply all these 3's. You're gonna get the same answer. So when I 3 into 3, do either any one thing. So when I do this, I'll get my answer as 729. And we know that 729 is a perfect square, and square root of 729 is 27. Yes. Now let us take one more example. So for next example, I'm taking my number as 1620. Let us find out what's the smallest number I have to multiply or divide for this number. So again, we have to go for prime factorization. So again, this number is even. I'm gonna do with 2. So 2 8s are 16, 2 1s are, and then 0 down. Now this is a again even number. You can either go for 2 or you can go for 3. So let me go for 2. 4s are 8, 0, 5. Okay, and then again this is again a odd number. It will go in 5 table. So 5 8s are, and then 81, and it will go in 3, 27, and again 3 9s are 27, again 3 3s are 9, 3 1s are 3. Okay, so I can able to write 1620 as 2 into 2 into 5 into 3 into 3 into 3 into 3. Okay, so here this will make a 1 pair, this is my second pair, and this is my third pair. Yes, so here this 1 5 is left, which doesn't have any pair. So for multiplying, which smallest number I have to multiply means I have to multiply with 5 so that I can make a 1 pair. And in case of division, which is the smallest number you have to divide, so this is a one number which I want to remove it because all other numbers are paired up. So the smallest number which I have to divide means the number will be 5. Now let us take one more example. Okay, this time I'll take a small number. Let me take 252. Okay, now for 252, again it's even number, so go into table. So 2 1s are, 2 2s are 4, 126, then 63. Okay, again 3 27, 3 7s are, and then 7 1s are. So 252 can be written as 2 into 2 into 3 into 3 into 7. Okay, so this will make a 1 pair, this is my another pair, and here 7 is left. So when I have to multiply with the smallest number, I have to multiply with 7 so that I can get a 1 pair here, and in case of division I have to divide with 7. So after multiplying, whatever answer you're getting, that number will be perfect square, as I have shown in my first example. So I'm not doing for this these two numbers. I hope you have understood how to do this. It's a very simple way, and this method, if any question is asked in your entrance exam or anywhere, which number to be multiplied, the smallest number to be multiplied or divide to get a prime perfect number, and then find the square root. So you can do this by prime factorization. I hope you have understood this method. Thank you.
watching நம்ம சேனல். இந்த வீடியோ உங்களுக்கு பிடிச்சிருந்ததுன்னா கமெண்ட் பண்ணுங்க, லைக் பண்ணுங்க, ஷேர் பண்ணுங்க. மறக்காம இந்த சேனலை சப்ஸ்கிரைப் பண்ணிட்டு பக்கத்துல இருக்கக்கூடிய பெல் பட்டனை ட்ரைன் தட்டுங்க.